I'm
Right.
not older than the internet per se.
Here we are. Hello, everybody. Welcome to PowerShell Wednesday. Every single Wednesday at 2 p.m. Eastern, we have PowerShell meetups. So always love it when you join us and you're here again. You can check out the recordings on YouTube every single week. Very special episode. And maybe we're going to tease some topics we'll talk about on a podcast that we'll record afterwards, James. But James, welcome to your first PowerShell Wednesday. And you're going to be talking about turtles in PowerShell, which I've dabbled with a little bit. I've seen this project of yours, and I think you're showing it off right there with your camera. But what are you going to be showing us today?
Um, cool old new stuff. So, for those who don't know me, hey, I'm James. I go by Mr. PowerShell on Blue Sky. I also have that domain. We're gonna get back to that in a second. I run a little consultancy called Start Automating. Do basically PowerShell work for whoever needs it. Customers are welcome to contact me. And I love building tools for the community and pushing the limits of PowerShell and helping, expand the pie and grow what we can do. Uh, Also, I guess this is like a fun fact of ancient history at this point. I helped build PowerShell V2 and V3, and have probably written a little bit more script than most people have gotten through in their careers, or most people out there in the world. So I'm pretty prolific. I also am a pretty old nerd, and one of the things that I kind of love doing is figuring out how to kind of take areas of technology that are available to everybody or ancient and misunderstood and bring them back in a PowerShell way. Um, when I was all of about 5, I was exposed to my very first, I'm going to call this a bit of a programming language in air quotes, Turtle, like on an Apple II in kindergarten. They had, turtles to play with in the computer labs. This was cool. This is how computers first learned to draw. And it was, you got this little turtle, you tell it to kind of go off in this direction, you tell it to move forward, and it's really fun for a kid to play around with. It was a really great way to kind of pique my interest and curiosity in programming and computers, and that's kind of lasted a lifetime. Well, I didn't realize until about 6 weeks ago, 8 weeks ago, that that's all that Turtle is fundamentally. It is, I am looking this direction, I've got a heading, and I move forward. And optionally, I can pick up or drop a pen so I can control whether I'm drawing. And if you're being really fancy, sometimes I can just go to a position or teleport to it. That's the fundamentals of Turtle graphics. And aside from that, it's just, rendering a path, which is something that I'm already pretty familiar with how to do. With technology that's also around for a very long time called SVG, scalable vector graphics. Those are basically a web graphics format that's been around since I think 1999 that lets you do web graphics in XML. So all we need to do to make a turtle in PowerShell is make a little property bag that knows its heading and can move forward and can turn that into an SVG path. And then bada bing, bada boom, we have endless beauty in web pages. And what I've got on the screen right now is an example of one of those. I can kind of show off the code for that later if we're interested. This one's one of the endless spirolaterals, which, other fun fact, is a shape I didn't know existed until 2 weeks ago. Um, but it's basically when you kind of create a spiral by only making turns of a particular set or size. So you can create a whole big polygon by just forward and turn, basically what Turtle does. And you create them in ways that, mathematically overlap. Bada bing, bada boom, you're good. And in PowerShell, since, You can turn anything into a short little script, and you can turn that into a command for your turtle. You or we can now just say turtle spiral lateral right settings here and get this exact graphic, or go to the examples and figure out how it was made. There are actually quite a few of them. I can kind of keep talking, or you can kind of ask a question here. Just let me know when is a good time to shut up and get to the next demo.
I want to see the README for this, the GitHub page, just to kind of get people pointed there and make it feel a little bit more real. Because to me, it is, you are a prolific and very creative PowerShell module writer. And to me, this is a pretty creative use of PowerShell.
Okay, this is not the README page. You asked me to read.
Can you share the screen the different way?
Which different way?
Actually adding it, like clicking present at the bottom.
Oh, I'm sorry. I thought we were doing that already.
I think we were. Might have been closed.
All right. So this is actually one of my own bits of docs on it. Let's go to the GitHub page, though, and show you the README as yet. So you can get to this GitHub, PowerShell Web Turtle. Like, share, and subscribe. Give me more stars, please. By the way, this is one of the many things you can create in Turtle. This is the Sierpinski triangle. Learned all sorts of fun terms building this. So you can install it just like any other module. You can import it just like any other module. You can clone the repo and go. You can use it as a GitHub action. Here's a bit of getting started. If I wanted to draw a square, I can do this by creating a turtle, moving forward, rotating, moving forward, rotating, moving forward, rotating, and saving that. I can also do this with a method chain because I like to build things that are flexible. So, I can say new turtle, and I could do turtle forward, rotate, forward, rotate, forward, rotate, symbol save. Or I could do this in a loop, or I could just go ahead and use turtle directly, or I could use turtle with a bit of PowerShell fanciness where I'm taking an array and multiplying it. And I guess I'm not including the simplest variation of this. So let's crack open some PowerShell for a second. Turtle square 50. Save square.svg. And yeah, we got a square.
And that that's invoke item. It kind of emulates a double click, or it opens it whenever your system default is.
That is correct. And yes, I did just zoom right over that. And I guess I did have the shorthand in there. I can also draw any number of other shapes this way. So if I wanted to draw a hexagon, there you go. Where it starts to get crazy and exceed the capabilities of various other turtles is you can basically go ahead and just say, I want to save off a pattern, or you can get the pattern property. So if I take our hexagon here, I'm going to go copy, paste, invoke item hexagon pattern. I think I might have had some fill settings there. Yeah, I don't want to strum them. I'll just go ahead and get rid of that. Actually, let's just go back to this and go to the more fun ones. One of the things I found along the path to this, in fact, like it was how I kept being reminded that turtle graphics were a thing, is I'd find documentation on a fractal, and it would say, see L system, see turtle graphics. And L systems are this way that fractals are drawn. You start basically with, let's go to the Sierpinski triangle here for a second. There we are. So we start with a couple of statements, and we expand any letter we find into this, and any other letter we find into this, and then we set an angle. And as it says, both F and G mean draw forward, plus T means turn left by angle, minus T means turn right by angle. So this was how these mathematicians of the 60s and 70s basically proved out all these cool fractals in the first place, is through turtle graphics. They're very old, very primal, and very simple, and very easy to implement. But I don't want you to have to go, figure this all out by hand. So in keeping with the pattern, I can go ahead and say, just make me one of these fractals. So I'm going to go ahead and say box fractal 5, 1, box fractal 5, 2. That's 5 is the starting size. Number of generations 1, number of generations 2, number of generations 3. And there you go. And you can do the same thing, basically, it's turtles all the way down. You can go ahead and create any fractal that way, change a few properties of it, save it, produce it as a pattern, and then we have stuff like this. And where were we? Let's go back a couple. Losing my place in my README. Where we get cooler again is that I can go ahead and do stuff like animate a pattern, because SVG can just do that. So I can take that same thing that I just created and I can automatically scale it and rotate it and skew it and translate it. And there are just two more mind-blowing things that I'm going to point out here. Would you like the markdown one first, or the how to make endless animations one first?
Let's do markdown.
Okay, so the way this file is built is a great example of metaprogramming in PowerShell. Sure, I've got my README MD, but I've got my README MD PS1, which has each chunk of my README being outputted one by one, and bits of PowerShell running along the way so I can get all of my examples preset correctly. And so I don't have to, repeat the exact same code that I just wrote for the example to draw the graphic that I want to show below the example. But yeah, it's just some PowerShell that outputs some markdown. And I just say readme.md.ps1, redirect to readme.md, and that's how it makes the readme. And now for the other end of mind-blowing, these examples are, a lot of these are called endless snowflake, endless box fractal. The reason they're called endless, is a bit of a lie, is the duration of the animations. If you wanted to make endlessly shifting or near endlessly shifting graphics, you can have a pattern like this. You can do various animations on it. These are very well known. These are not, I did not have to write scalar math myself. SVG is doing this for me. The browser is doing this for me, right? So I'm saying I want to scale between 1/3 or 2/3 and 1/3 and 2/3 over 23 seconds, and rotate over 41, and skew it a bit over 83 and 103, and translate it a bit over 117 seconds. And there is a gold star to anybody who can already tell me what is different about these numbers.
Not me.
They're all primes.
I just saw it. Thing.
So prime numbers, by their very nature, do not overlap that often. This is one of my favorite little tricks to rediscover in various incarnations. I first ended up using prime hacks when I was trying to kind of optimize performance of data collection. So I'm trying to collect like something from like 50,000 boxes as quickly as possible. Everybody says every 5 minutes is as quickly as possible, but if you do that, you slam the boxes every 5 minutes. So how do you break up everybody's requests and not overload the boxes? Well, if all of the scheduled tasks are set at prime number intervals, then they're not going to overlap that often, just like multiple broods of cicadas don't come out of the ground that often. But what's cool about this is you can calculate it. So I can actually tell you how long. Let's do this the PowerShell way. Let's see. We got 23 times 41 times 83 times 103 times 117. So this endless example, not math, time span from seconds will repeat every 10,916 days. Sorry. So, just 30 years from now. So it's not technically endless.
Wait, what was that equation? What did that do actually?
This is proving how long it will take this animation below
To have a collision?
to repeat.
Oh, to repeat. So it's unique for 30 years, basically.
Yeah. So you're taking this, you're scaling it, you're rotating it just a little bit each second. But because each of these things are happening at different total intervals, each moment is, different than it would be for another 30 years. So all of these examples, I mean, it's not technically endless, sure, but this is going to be repeating far longer than my browser tab is going to be open. I don't care how lazy I am about turning off my machine. Everybody has a power outage from time to time.
And I think that tip about prime numbers, though, it could apply to other areas. Like it's a good
Oh,
thing to kinda
that
keep in
is
your back pocket.
it is a wonderful thing to keep coming back to and to keep understanding. It is really, really incredibly useful in all sorts of contexts, and I keep finding ways that primes are helpful in performance and systems design. They're really great at what they do, which is ensuring that they don't overlap that frequently.
I got a good question here. I want to
Sure.
answer it from my perspective, and then I'm curious to hear yours. Good buddy Trent says, "Does anybody have any use cases for this module in mind?" And in my opinion,
Graphs. I'm going to build you all the graphs.
oh, graphs. But here's my takeaway, because if you look at your README, this, I love when people are trying to learn PowerShell. You need to find excuses where they can actually get kind of hands-on and interact with things. Given their roles and their environments or test labs, they may not always have the best kind of setups here. This right here is a great way to learn a whole bunch of concepts in PowerShell. Manipulating files, right? You're outputting the SVG in a certain folder. You're needing to invoke item on it, like getting comfortable with the pathing. There's a lot more advanced techniques when it comes to like calling the methods to do the forward and stuff like that. Like it introduces you to a lot of stuff in a quick little package, and you get cool images from it. So, I mean, for me, selfishly, I'm going to be recommending this to a lot of beginners that I talk to and exploring how helpful it is in that journey. But
Yeah.
James, what about you?
And I mean, that's definitely going to be part of it. I wanted to build something that was both effective at, drawing beautiful things, giving me that kind of endless beauty from PowerShell, but also I wanted to make something that could be used to inspire and learn in the same sort of ways that I first kind of fell into programming. Not that I even realized it as, a 5-year-old self, but like if you have, kids or are otherwise like, teaching anyone and you want to give them something that feels tangible, graphics are a wonderful way to do that. They're also one of those things that it seems like most people feel like they're like S tier level of development, and they're actually kind of not. Like it's an ivory tower bit of crap. This is somebody who has, speaking of somebody who has done graphics programming either professionally as a hobby for, oh dear, I feel old, 20, 30 years now. A lot of what, you know, graphics programming is, especially nowadays, is very simple logical programming. It's the same as anything else. You do not need to build the faster Doom engine. You haven't needed to build that since like 1997 or 8. A lot of the techniques for building 2-dimensional and 3-dimensional graphics are, in fact, actually older than like PCs. Like Turtle as a language is from 1966.
You said Turtle as a language?
Yeah, Turtle as a graphics language has been around since 1966. Logo, the language Turtle was first built in, is the language used to run the Apollo program and send us to the moon. It's also a wonderful inspiration for PowerShell because Logo was built around simple, readable syntax and, verbs and nouns. So I wanted something that could both kind of connect to that era of past and also make it just as easy to approach PowerShell and programming as it was for 5-year-old me. And this is actually kind of a great little transition point to another thing that kind of keeps coming back. Learning techniques is better than understanding how to use a tool. There's a lot of really simple techniques that are buried over and lost because people are using tool built upon tool, built upon tool, built upon tool, built upon tool that they don't understand or control. A lot of these, ivory tower graphics programming techniques are basically figure out how to draw as quickly as you can, which is a solved problem. In this case, I just literally tell the browser to do it. I give it a format the browser has been happy with for 20 plus years, and it uses it. And then draw a bunch of points. So going back to the Turtle, OG, I have a heading, I rotate, I move. And this actually gets considerably more useful and trippy once you start to take it into the real world. A couple weeks ago, I got a very old book written about Turtle. It was written in 1980, which means the book is technically older than I am. Although the printed copy I had is probably a year or so younger. But this book is so old that I actually found a punch card in it as a bookmark. And this clued me in onto the way that Roombas or bots work is also Turtle. The way that you model basic AI programming is all in geometric space. The way we operate in the world, it's turtles all the way down. If you think there's a fire, okay, you're smelling, okay? Like, where is this fire? I smell stuff more to the left, more to the right. Okay, now I move closer to this until I can actually see it with my eyes to figure out if there's something I need to do about it. So you can model all of these real world problems with Turtle. They have been modeled with Turtle for longer than I've been alive, 60 odd years now. And this can open up this whole wide world of real world programming and graphics programming into PowerShell very succinctly, very easily, and give you all something that you can kind of use to teach others. Not just this is PowerShell, but this is the great lineage of trying to make tech easy that PowerShell descends from. And here's all the cool stuff you can do with it. You do not need to be a C++ genius to draw stuff to the screen effectively. Doesn't hurt. Well, actually, it kind of does, because it gives you a bias to using C++ in 2025. So, yeah, rant mostly over. I'm going to switch up the animations a bit and go to something we showed just before the thing, which is the demo page, which also shows off how you can build web pages in PowerShell. So here's just a quick showcase of various things that Turtle generates out of the box. This is actually also a little out of date. I need to add a few more new coolnesses. But yeah, here's a bunch of fractals. Enjoy. Where it gets cool is I can just go ahead and view the source here. This is a PowerShell script generating this, because it's got help, right? You got a synopsis, which is actually going to become my title. You got a description, which is going to become the description for search engines. Then you got my notes. And hey, turtle graphics are pretty groovy. I'm kicking it since 19. What's going on here? I'm turning my notes into the web page. I've also got a link to the web page, so when I go to this script and I say get help -online, it'll actually open up the finished copy. But yeah, here we go. We're going to go get my own metadata for my help. Page is a magic variable that I'm going to use to maintain page data. And, if it's in a dictionary, I'm going to go ahead and throw in a preview image there. And if I have notes in my help, I'm going to go convert that from Markdown and spit out the HTML. And there we go. There's my notes. And then if I wanted to do the view source, I could just spit out a bunch of HTML tags. You could just do this, no tooling required. You've always been able to, since PowerShell V1, write a web page this way. All right. You can write, in fact, any language this way. You can spit out a bunch of strings and redirect files. So I'm going and creating a details. I'm going and creating a grid, just a little CSS. Don't be scared. These are really good ways to kind of automatically lay out a bunch of stuff. If you don't know too much CSS and you don't want to know too much CSS, know that display grid is your friend, and grid template columns, repeat autofit, give it a size, call it good. So we're saying make it as many columns you can and figure out the right one to use between 500 pixels or one fraction screen. Give it 2.5 emphasis points between and 2.5 emphasis points as a margin. Make everything center inside of that, and then I'm going to make a bunch of turtles. So here are all my fun examples. There they are again. And you can see that each turtle is basically a one-liner. Extra bonus cool points. This is done in a GitHub action or GitHub workflow. And so when I run this, when my bot runs this every build, it's actually picking a new random flower. Not that different. I'm only switching, one variable in it. So I'm picking between 4 and 6 as the random parameter to this. By the way, a flower is built by basically turning a square or a polygon n number of times. So I'm saying either make it a square flower or a pentagon flower or a hexagon flower. Okay. And then I'm doing a bunch of other turtle one-liners, put it into a dictionary. Then I go start to spit out my grid by creating a div, put a div for each one, walking over that, for each turtle name and keys, give it a header, and all I need to do to throw this into a web page is stringify it. So this is the web page you're seeing, this little bit of PowerShell. All these endlessly cool graphics, whether you want like cool web page background or cool graphs or anything that you want, you can do in a small number of lines of turtle, which you can throw into a web page with the string, and you can group them in hash tables if you want. You can do the whole bloody thing inside of a GitHub workflow and have, again, endless, ever-shifting beauty, all been built with PowerShell, all simple, all easy, and all hopefully understandable enough to teach your kids if you have them, or explain to random passerbys if you're that sort of schmo. So
let me tell you about turtles.
Oh, I've been having a blast making strangers understand like the lineage of computer graphics, because I didn't understand just how short this journey was until 6 weeks ago or so. It's like, oh, this plus that are your fundamental pieces, and it is turtles all the way down after that.
And in its simplest form, turtle just means go direction, make turn.
Yeah,
That's kind of it.
you got
And
it.
you've put that into PowerShell with you create turtle, and then you give it some ways to turn, you give it some numbers, and then boom, you get this crazy stuff.
Yep.
Can we see the code to make one of these? Because I cannot imagine.
Yes, to make one of this.
Yeah, like one of those individual patterns. Because I see you have a little helper thing where you can just call it by the name of like the predefined ones.
Okay. Sure. Let's take the flowers as a good example, because that one's actually, yeah. That's getting a little too advanced right there. Let's do save turtle flower.svg. So this is the one that it's randomizing each time. I'm doing a couple of extra things to it. I'm giving it a stroke and a fill. Let's get rid of those to take it back to its old school. There we go. And every time I run this, I'm getting a slightly different variation. Let's go ahead and open this parameter up a bit, and let's give it anything between 4 and 10. So endless beauty. Let's see how flower is built. So the way I built turtle, you don't have to build it this way. You can implement it in a class. You can implement it any way you want. But the way I did it was in an extended types file. So let's start with our rotate, because that's the easiest one. Okay. I just add a heading, or add my angle to a heading. That's it. I've rotated. Okay. Move forward. This takes a little bit of math understanding, but not too much. This is a thing, basically a polar coordinate or a vector. So it's saying I want to go a distance at an angle. Distance is what I'm providing, and angle is the heading. And then this is the, quite frankly, BS that you have to do every time you deal with degrees and radians. But it's basically taking the degree that heading is in and turning it into the form that the math class is happy with. And now I know the relative distance. And I can go ahead and change my position to that and update my steps. Okay. So then let's go look at flower. I think we have one more in between that we have to look at. Yeah, let's go look at polygon first. So if I wanted to make a polygon, any number of polygons, let's do turtle polygon, yeah, 42.6. Save hex.svg. Cool. Now I guess septagon maybe. I don't remember the name of this, so I'm just going to call it poly 7. I think it's a septagon, but I don't care. Let's do poly 5. I didn't even change my file name. Oopsie. So I'm just going to call it poly from now on. And let's go a little bit further up. Let's make a dodecahedron. Gotta open the right file. There's dodecahedron. And let's go a little bit further up. And let's go a little bit further up again. And can you kind of see what happens with a polygon as you add more and more sides to it?
Gets more cooler.
Gets to be a circle, basically, or infinitely approximates a circle. Well, not infinitely. In fact, if I go ahead and do a polygon of 360, this is one of many ways to draw a circle.
Interesting.
Okay. But now we got polygon understood. So let's go look at our flower. Remember, a polygon was built by forward and rotate. Rotate is just hey, I'm heading this way now. And forward is just, all right, if I was along a circle heading this way, how far is X? How far is Y from where I'm at now? Okay. And then flower is I have a polygon of whatever size and whatever side count. I'm going to rotate after I make that polygon whatever amount. And I'm going to do this number of steps. Let's see. Yeah, let's just do this on the fly. So let's do turtle flower. Let's be fancy. We already did that one. I don't really want to change up the size that much. What I want to do is I want to change up the rotation step count. So I'm going to give it a bigger rotation. And I'm going to keep trying to keep my math right for a second. And I'm going to give it a half of the step count. Okay. Cool.
Tracking.
Okay. Now I'm going to make it wrong. By making it wrong, I mean I'm going to make it draw more than a complete circle and incorrectly with an uneven number of vertices or of a rotation that won't naturally equal 360 as I scale it. Okay. That one ended up a little too close to the other one. I'm not quite sure why. Oh, yes, because it's only a slight change in the repetition. Let's go 82. Now, I can't actually really see that this isn't properly closed. In fact, I don't even know if I need to discuss what properly closed means. Do you want me to?
Well, I have no clue what it means.
Okay, so if you keep doing this n number of times, you'll eventually end up at a multiple of 360. And that will close a circular path. So if I wanted a shape that was closed, right? Let's do this with a really small multiple here. So I'm going to do 42, and I'm only going to do 4. And then we're going to do 5. And we're going to do 6. Now 42 times 360 divided by 42, 8.5. So we're not going to evenly go around a circle. We're going to start to overlap ourselves. So 7, now we look like we've completed the circle. We haven't technically. 8, still look like it, but haven't technically. 9, now we're on the next rotation. And if I go to something like 120 of this, so you're seeing how this sort of works step by step to draw shape. Kind of, maybe.
Yes, it's clicking. It's
Cool.
causing me to think very deeply.
Cool. That's the joy of Turtle graphics and of what this can inspire and do. It's like, it's really hard to like look at the ivory tower of how to do anything graphical and basically be like, where do I even start climbing? It's a lot easier to basically be able to kind of iteratively explore a shape you're building. And that's what Turtle is designed to give, you know, myself, any other programmers, anybody wanting to learn computers, mathematicians that need to use it. Yeah. So this continues to get endlessly awesome. So let's do a get random min of, let's do 40. No, min of 20, max 60. We're just throwing stuff in here, and we're going to do a, I want it to almost always complete a circle. So if I did 30, we already, or 20, we said our step count has to be at least 18. Let's say with 60, our step count would have to be smaller than that. So I do actually want it to overdraw a number of times. Let's go, let's just give it 180 and call it good. Okay. Let's do this the PowerShell way. I should probably add more in the verbose here. So yeah, I do really mean endless beauty from PowerShell. I'm gonna just leave it with that one because that one's
good, dude.
Pretty nice.
That's wild.
Yeah, and that is all built upon effectively 2 operations.
What?
I go forward, I rotate. I'm doing a polygon a number of times, which is again a number of forwards and rotates, and I'm doing that a number of times. So I guess it's a for each of a for each, effectively. Or it's just, give it a bunch of random points to see what looks cool. Hey, boss, I got a new logo for you.
Wow. Impressive. I'm a turtle fan. An animal lover at heart.
I mean, we all have our problems. No, I kid. Definitely a bit of an animal lover myself. Though I have not yet figured out how to draw a pug and turtle. I will get there eventually.
And that would be impressive. Like an Etch-a-Sketch of sorts.
It would totally be possible to draw an Etch-a-Sketch and turtle. Think about it. Okay, what happens when you move the pen?
It goes.
Yeah, it's moving forward, right?
No, I meant Etch-a-Sketch in terms of that was how you would draw the pug. Would be like that kind of thinking. One line at a time, turn, boom, boom.
But I'm also thinking, like, if you wanted to implement ink, if you wanted to have something you actually drew out with your mouse or with a pen and turn it into turtle, that's actually kind of trivial if you stop to think about it. Now that we understand turtle, because that's what the pen is doing too. I'm either attached to the paper or not. The pen is heading an angle and it's moving forward a distance. Whether our brains are stopping to realize that this is what's going on or not, that is literally what the act of drawing is. So, yeah. Let's do it.
True. Just got to keep track of it all. Well,
yeah, this is the sort of, again, joyful inspiration that I want to bring to the PowerShell world and to the tech world overall. It's what makes life fun. And I am having an absolute blast with the turtles in a PowerShell. So, I would love to see what you can all do with your newfound turtle power. And,
I like the sound of that. Turtle power.
Yes. I also would love for us to hijack a hashtag a little bit. And I can't wait for the first of us to figure out the secrets of the use.
Awesome. Well, this is really cool. I definitely recommend giving it a try. As you saw, you can do some pretty powerful stuff easily, but also there's the room to dabble. And if you're new to PowerShell or you deal with people who are newer to PowerShell, curious if you have good experience like showing them this as a way to start interacting with files, writing PowerShell that actually does things that you can see the result of, and maybe some other like piping things together is also another really good one.
Oh, yeah. I keep wanting to build a quick little file visualizer this way, but I realized basically all you need to do to draw a file tree is keep going down, branching out, rotating, and then drawing like a square of the square root of the file size. And then you'd have a pretty good sense of here are all the files. Here's how big they all are. So I'm really looking forward to data visualization being easy for all of us with, again, our newfound turtle power and turtles in a PowerShell.
Keep our eyes on that. But speaking of eyes and speaking of keeping them on places, people want to hear more from you, see what else comes down the road with turtles and more. Where can we find you on the World Wide Web?
Yeah, that newfangled thing. So I am again at Mr. PowerShell on Blue Sky. You can also go to mrpowershell.com and find this particular page and various other fun experiments. You can see me on Twitter if I ever show up on there as James Brew. On GitHub, I am Start Automating, and I have a few different other organizations you can join. You could join the PowerShell Web organization if you wanted to help build any of these things out. And yeah, on an individual level, you can also visit startautomating.com to hear about the consultancy, or make my day and see if you got a cool gig to offer. Because good PowerShell hands are always looking for work. And yeah, I would love to help anybody build awesome stuff in PowerShell that wants to build awesome stuff in PowerShell.
And I know that you can build some awesome stuff in PowerShell. That is definitely a known. So
I think, I'm not sure. I mean, my turtle powers are good.
We'll have to put it to a test in the podcast we'll be doing. Keep your eyes out for that in coming weeks. Thank you, everybody, for joining us for PowerShell Wednesday. My mind is blown, man, to be honest. Like, kind of got me thinking like big life like universe patterns, got me thinking PowerShell.
Oh, yeah.
Got me thinking a lot of stuff. Got me thinking about the
when
benefit
they
of old
do
secrets.
a model of the universe, when somebody writes a modeling program for that, what do you think they're doing to render it? They're building things on top of a layer, on top of a layer, on top of a layer, on top of this fundamental understanding of turtle.
Yep.
Yeah. You want to do orbital dynamics? You could totally do that in turtle. That's what it was first made for. It got us to the moon. I think it worked.
Well, I have no clue what orbital dynamics is, but maybe I'll learn more about it here in a minute. But thank you, James.
So.
There's always more time to learn. But we'll see everybody next week, Wednesday, 2 p.m. See you there.